Since its foundation in 1856, KWS has pursued the goal of offering farmers increasingly better seeds and high-performing varieties. The methods and tools have been continuously developed. In addition to traditional crossing and selection, robots, drones, artificial intelligence, market technology, and genome analysis are used today. But plant breeding is and always will be handcrafted, a labor-intensive, time-consuming process that breeders like Jens Leien carefully plan and accompany over many years.
We are developing varieties that combine positive traits such as high yield performance and strong resistance to diseases.
In addition to yield, climate change and the regulation of chemical crop protection are bringing other breeding goals more into focus.
Diseases such as Cercospora, Rhizomania, and virus yellows are spreading worldwide and are playing an increasingly important role. That is why we are working intensively on the development of resistant varieties that enable farmers to grow sugar beet sustainably in the future.
In the laboratory, traits such as resistance can already be detected at the genetic level.
One plant has around 30,000 genes. Our task is to identify exactly those genes that lead, for example, to the multiplication of virus yellows.
Markers can be used to determine within 48 hours whether a certain property is present. The uniqueness of the marker profile of a plant makes it comparable to a human fingerprint.
With the help of special software, we can compare thousands of marker profiles with our field-measured data, enabling us to identify the most promising genetics for field trials.
But the desired information is not always captured in the data from the laboratory, which is why the knowledge and experience of the breeders is so crucial.
The generative phase in which plants can be modified by breeding is very short. That's why breeders need a good understanding of their material and must consider and develop strategies in advance.
Breeding expertise also enables a solid assessment of digitized processes. So far, digital tools and artificial intelligence have been used primarily in established breeding programs and for processing large amounts of data.
Drones can be used to achieve high precision in resistance assessments. The challenge is to achieve such exact calibrations as the human eye, or even beyond wave ranges that are invisible to the human eye.
And the interpretation of the data is also crucial for the right conclusions.
The human eye sometimes comes to more differentiated results. So even a parcel that looks affected at first glance can have well-performing plants.
Only 10% of the genotypes that go into performance testing are produced in the foil houses the following year.
You can think of breeding as a kind of funnel. It is screened and filtered again and again until the material with the desired properties remains. We are always looking for new, better solutions for our toolbox to speed up the breeding process. In the face of climate change, we need to find breeding solutions to challenges such as drought stress, pests, and plant diseases. In this sense, our work has an important social component because it benefits people in the end.